Thank you for watching this presentation on line sizing. We hope you to find this time well spent and also informative.
My name is Chad Ackner. I'm the Technical Service Advisor for Dealers LP Equipment and the R.E. Michael Company. R.E. Michael has corporate headquarters in Glen Burnie, Maryland, while Dealers LP Equipment has locations in Davenport, Iowa, Louisville, Kentucky, Hickory, North Carolina, Jackson, Mississippi, Dothan, Alabama, and also Memphis, Tennessee. It's important to note that anything discussed today should not in any way be construed to override any of your local applicable codes, any of your insurance requirements, or any of your company policies. Anything referenced today is from NFPA 54 and also NFPA 58. All propane installations must comply with both NFPA 54 and NFPA 58. Those installations must also comply with your local AHJ, or authority having jurisdiction, which may be a local code enforcement agency or a fire marshal. Company policies must always be followed in addition to following manufacturer's instructions. Part of the code is to actually follow the manufacturer instructions, whether it pertains to NFPA 54 or NFPA 58. So that is actually written into the code. Always work safely, document everything that's performed during the installation or during the service work, and retain all documentation. A breakdown of the differences between NFPA 54 and NFPA 58 are that NFPA 58 will cover everything from the container all the way up until the outlet of the delivery regulator. Now that may be an integral twin stage regulator or a second stage regulator. NFPA 54 covers everything from the outlet of that very same regulator all the way inside the building.
The most effective way to watch and participate in this pre-recorded seminar on line sizing is to make sure you have a REGO L545 or LP Gas Serviceman's Manual. In addition to that, I recommend you download the free REGO app to your smartphone. Probably the most common piping installation an LP gas service technician will do is low pressure 11-inch water column piping systems. Today we will be discussing and sizing some low pressure installations as well as some other things. Part of the conversation today will be twin or two-stage vapor piping, first stage vapor piping, 2 psi vapor piping. We're going to discuss a little bit about liquid piping and also some generator piping tips. Low pressure piping applications can be viewed as either twin stage installations or two-stage installations. A typical twin stage installation generally occurs when the container is closer to the building, whereas a two-stage system, oftentimes the container is set out away from the building, allowing the use of high pressure from the container up to the building, where the second stage regulator will drop it down or reduce it to operating pressure, 11 inches water column. You'll note in this slide that a twin stage regulator is the same color as a second stage regulator. That's because REGO identifies these regulators by the outlet pressure they're set to. So a brown regulator indicates that this regulator is set for 11 inches water column. Additionally, when sizing a regulator for either a twin stage or a two-stage installation, always compare the BTU capacities of the compact and the standard size. If the BTU load of the job is close to the capacity of the given regulator or the smaller regulator, always move up to the next size. By looking at this slide, you'll notice that not all copper tubing is the same. K-copper, L copper, and refrigeration copper all have different IDs, inner diameters, and ODs, outer diameters. When sizing a propane piping system, make sure that the copper tubing type matches the application. Start out today by sizing a very simple low pressure piping system for a residential application. The very first thing we do whenever we're sizing a propane piping system is to add the total number of appliances that this system will be required to supply. In this case, we have a 30,000 BTU room heater, a 38,000 BTU water heater, a 35,000 BTU clothes dryer. All three appliances have a total of 103,000 BTUs. Remember, propane appliances operate at a low pressure of 11 inches water column. Now is also the best time to ask the property owner if they're going to be adding additional appliances. Provisions should be made now if appliances will be added in the future. Oversizing the line to account for the additional appliances will save time in the long run. The next step to size a second stage or twin stage vapor piping system is to take a measurement from the outlet of the delivery regulator to the inlet of the appliance that's farthest away. In this case, it's the outlet of the twin stage regulator to the inlet of a clothes dryer. That's the only measurement you need when sizing a piping system. The next step would be to make a simple sketch or a map of the piping installation. The next step is to determine which table in the L545 we're going to use, and also which column we're going to use with regard to the length of piping. Remember, we're sizing a low pressure 11-inch water column piping system. And in this case, we're going to be using either copper tubing or black iron pipe, schedule 40. Also remember that when we took that measurement between the outlet of the delivery regulator and the inlet to the appliance furthest away, it was 97 feet. Well, if you look at the columns on table 3, you'll notice that there is no 97-foot column. So what we choose in this case is the 100-foot column. You always want to use the column longer or the number higher than the actual measurement. You never want to go down, you always want to go up. This 100-foot column on table 3 will be used for every piping measurement that we make. In other words, the main trunk line from the regulator to the first tee, from the tee to the space heater, from the tee to the water heater, and also from the length of piping to the dryer. So regardless of how long these actual runs are, the 100-foot column will always be used in this particular application. Using any of the pipe sizing tables in the REGO L545, it's easy to see the length of the run or the number of feet in the run in the light blue shaded area on top of the chart. Also below that, you'll see a series of numbers in the columns. Those numbers represent the BTU value for that size piping or tubing based on that run or that length of run in the thousands of BTUs. The first section of piping we're going to size is what I call the trunk line, the section of piping between the regulator and the first tee in the system. This section of piping is going to be required to handle the entire BTU load at any given time, so it has to be sized, in this case, for 103,000 BTUs. Remember, using the 100-foot column, we're going to size this piping. We know we need at least 103,000 BTUs. So if we go down that 100-foot column, we finally see a number that's over 103,000. It happens to be 3/4 inch black iron pipe. So we're going to choose 3/4 inch black iron pipe for this application, this main trunk line, which will give us 175,000 BTUs at 11 inches water column. The next section of piping in this installation is the section or the segment of piping between B and F, or the first T in the system, to the inlet of the 30,000 BTU space heater. Again, using that 100-foot column, we go down and we look for the BTU value or the number higher than 30 or higher than 30,000. In this case, we're finding 54,000 for 5/8 copper tubing or 84,000 for half-inch black iron pipe, depending on what material you will be using. So again, in this case, we're going to be using either 5/8 copper or half-inch black iron because the numbers represented in the 100-foot column are higher than the BTU value that is required for that heater. Next up is the segment between B and C, or the section or segment of piping that comes between the first T and the second T. The BTU value that this piping is required to handle is about 73,000 BTUs. We had 103,000 total BTUs to begin with. We've just dropped out, or we've just accounted for 30,000 of those BTUs. So now really all this piping is required to handle is 73,000 BTUs. So again, using the 100-foot column and going down, the first two numbers we see, again, one being copper tubing and one being black iron pipe, depending on what material you're using, is 3/4 inch copper tubing, giving you 95,000 BTUs, or half-inch black iron pipe, giving you 84,000 BTUs. Those are the first two sizes that are over the 73,000 BTU threshold. Next is C to E, between the second T and the inlet to the water heater. Again, using that 100-foot column, we're looking for numbers over 38,000 BTUs. So we find 5/8 copper tubing with a value of 54,000, or half-inch black iron pipe with a value of 84,000. Either one of those two selections will work for this 38,000 BTU connection. And the last section of piping between the second T and the inlet to the clothes dryer furthest away, again, using the 100-foot column, we're looking for numbers over 35,000 BTUs. So again, in this case, we find 5/8 copper valued at 54,000, or half-inch black iron pipe valued at 84,000 BTUs. So what have we learned here? We've learned basically that we're using the same column for every pipe measurement based on the longest run between the outlet of the delivery regulator and the inlet of the appliance furthest away. And we've also learned that there are different materials we can use to accomplish the same thing. My guess is in this particular installation, the installer would run a 3/4 inch trunk line based on our calculations, and then either continue for the entire installation with 3/4 inch black iron, or branch down to half-inch black iron to complete the installation. Either one would work, provided no appliances will be added in the future. What's often overlooked when sizing a piping installation is accounting for the fittings. On page 48 of the REGO L545, you'll see the representative equivalent lengths of pipe for various valves and fittings. For example, a 3/4 inch Schedule 40 90-degree elbow equals nearly 2 feet of piping. So for example, if the equivalent length of a 90-degree elbow, Schedule 40 3/4 inch, is 1.8 feet, and you had, say, for example, 10 elbows in an installation, you would have to add 18 feet onto the overall length that's measured from the outlet of that regulator to the inlet of the appliance that's furthest away. We've just sized a very common 11-inch water column low pressure piping system for a typical residential application. Remember, propane appliances operate at 11 inches water column inlet pressure. Well, now we're going to size the first stage side, or the high pressure side, of a two-stage installation. And this could be either a conventional two-stage installation or a two-stage 2 psi installation. The first stage side of either one of those installations is sized exactly the same. So in this particular application, this first stage side of this installation, we have a 338,000 overall BTU load. We're going to be sizing our first stage side of this installation using both copper tubing and also poly pipe in two separate charts. So now we make sure we switch tables in the REGO L545. In this case, we're going to be using table 1. We're going to be sizing the high pressure side or the first stage side of this installation using copper tubing. So in this particular case, again, we have a total BTU load of 338,000 BTUs. We have a 26-foot run from the outlet of the first stage regulator to the inlet of the second stage regulator. If you look at the chart on table 1, we're going to be using the 30-foot column in this case because it's higher than the 26-foot length that we have in our installation. So using the 30-foot column and remembering that we have a 338,000 BTU total load, which size copper tubing would you use or could be acceptable for this particular installation? By going down and looking, we see that half-inch copper tubing with a value of 584,000 BTUs at 10 psi and at 30 feet would work for this installation. If the goal is to use polyethylene pipe, we want to make sure we change tables in the book. We want to this time use table 2. We have that same installation we're sizing, so again, we have a 26-foot run from the outlet of the first stage to the inlet of the second stage. And on table 2, we're also going to be using the 30-foot column. There is no 26-foot column. So with the understanding of a 338,000 BTU load using the 30-foot column, we're going to be using half-inch CTS, which will get us over 700,000 BTUs. On the left side of table 2, the poly pipe chart, you'll see the letters SDR. SDR stands for Standard Dimensional Ratio. It's the ratio of the pipe diameter relative to the wall thickness. Poly pipe with a high SDR indicates that the pipe wall is thin, compared to a pipe with a low SDR ratio or reading, which would indicate that the pipe wall is thick. The key here is to make sure that the fittings used with the selected poly pipe match. In other words, the sizing matches and also the SDR matches. Otherwise, you're going to have fitment issues and also the potential for a leak. A quick note about CTS copper tube size versus IPS iron pipe size. Depending on what type you're using, make sure you follow the proper line on table 2. This is where the SDR notification comes in. If you're using half-inch CTS with a 7.00 SDR, make sure that you're using the proper line in addition to proper fitting selection. If you're using half-inch IPS with a 9.33 SDR, make sure you're using the proper line for that material, again along with the proper fittings. Half-inch IPS nearly triples the BTU capacity of half-inch CTS. Therefore, making sure you're using the proper line when determining the pipe sizing is critical. We've just sized the high pressure side or the first stage side of a two-stage installation. Well, let's say that this two-stage installation happens to be a 2-pound system or a two-stage 2-pound installation. There are separate charts in the L545 for reference when sizing a 2-pound system. Let's make sure we're doing it properly. The first thing is to make sure we're using the correct table. If you're going to be using CSST, for example, in this 2-pound installation, you want to make sure you're using table 4, which is the CSST 2-pound table. In this particular case, again, we have that same 338,000 BTU total load, but this time we're sizing it from the outlet of the 2-pound second stage regulator to the inlet of the line regulator. In this case, we have a 19-foot run, so on table 4, we're going to select the 25-foot column. We have a 338,000 BTU load, which, following the numbers down, tells us that we can use a 3/8 CSST. Please note, though, that this 3/8 CSST has to be 15 EHD, or equivalent hydraulic diameter. The letters EHD, or equivalent hydraulic diameter, represent a measurement of the relative hydraulic efficiency between the different CSST sizes. The greater the value, or the larger the EHD number, the greater capacity the CSST has. And again, depending on what type of CSST you're using, always make sure you're using the proper line on the chart. In this case, again, the 3/8 CSST that we were using, or that we selected, had a 15 EHD, meaning it would supply all of our appliances properly. If you've decided to use copper tubing for that same 2-pound installation instead of CSST, make sure you're using the proper table, table 6 in this case. Again, we have a 19-foot run, 338,000 BTUs. Following on table 6, the 20-foot column, because again, it's just over the 19-foot length, it tells us that we can use either 1/2-inch copper tubing or 1/2-inch black iron pipe. Either one of those two selections will more than handle the 338,000 BTU load for this installation. We've put together some BTU comparisons between 11 inches water column systems and 2-pound systems, basically using the same size and length of piping, but the value at 11 inches water column and the value at 2 psi. You'll notice that with any of the comparisons, the value of a 2-pound system over an 11-inch water column system increases by nearly 9 times. So for example, a 40-foot run of 3/8 copper tubing will get you 21,000 BTUs at 11 inches water column, but 195,000 BTUs at 2 pounds. A 70-foot run of 1/2-inch copper tubing will get you 32,000 BTUs at 11 inches water column, or 297,000 BTUs at 2 pounds. 80 feet of 19 EHD 1/2-inch CSST goes from 52,000 at 11 inches water column to 393,000 at 2 pounds. And 100 feet of 3/4-inch black iron will get you 175,000 BTUs at 11 inches water column and 1.61 million BTUs at 2 pounds. Now remember, that is a simple regulator conversion, or a simple regulator swap. Piping is not changed, fittings are not changed. The only thing we're doing is we're swapping out either the twin stage or the second stage with a 2-pound version of that same regulator. In addition to that, we're always going to be adding a line regulator to bring it back down to 11 inches water column, which is what the appliances operate at. We're going to spend a few minutes talking about generator piping and generator connections. Generators are a little bit different than a standard propane appliance in that when a generator starts, the internal combustion engine will actually suck the gas out of the gas line. It's not a standard combustion process like a furnace or a pool heater or something like that. So we have to do a few things differently and make sure that we follow the manufacturer's instructions to make sure that we supply these generators with a proper amount of fuel for not only startup but also run. It's important to make sure that we're supplying these generators with a proper amount of pressure. Generac and Honeywell require the inlet pressure to a 9 to 22 kW propane generator to be between 10 and 12 inches water column. It cannot deviate from that inlet pressure setting. Supplying a generator with 9 inches of water column or 13 inches of water column will give that generator startup issues. Pressure that drops below the 10 to 12 inch water column spec for propane fired generators most likely will indicate a pipe sizing problem. Generators do require a slightly different pipe sizing procedure. Understand that the generator inlet size does not affect the proper gas piping size. If the piping is sized at 1 inch based on the length of run and the overall load, but the generator has a 3/4 inch inlet, it will not affect the performance of the generator. When using the pipe sizing charts in the generator installation manual, it's important to note that the piping determined is based on sizing the piping at the pressure the generator operates at. For example, if it's a two-stage system, the overall length only includes the low pressure 11-inch water column side. The high pressure side is calculated in a different calculation. In looking at this example in the Honeywell installation manual, and again, sizing this piping at 11 inches water column, or what the inlet pressure of the generator is, we understand in this example that we have a 22 kW generator with an inlet pressure of 11 inches water column. The length of this particular run is 18 feet. So to size this piping properly using the chart in the Honeywell installation manual, we go down the left-hand column and find the 22 kW generator, follow it over to the right and find the number that represents the next highest amount over our run. So for example, our run is 18 feet, we go over to 20, representing 20 feet, because this piping size will account for or will accommodate up to a 20-foot run for a 22 kW generator. We find the 20 feet, we follow it up to the very top, and it tells us that a 20-foot run of 3/4 inch pipe will account for and accommodate a 22 kW generator at 11 inches water column. What about potential generator startup issues? Some manufacturers explain and recommend that installing piping one size larger than what's recommended in the owner's manual at the last 10 feet of the piping run at the generator may help with any startup issues. Another thing that's possible is to install a 2-inch nipple with 2-inch by 3/4 inch bell reducers at the unit as well. Sometimes this provides just enough storage capacity at the generator to help with any potential startup issues down the road. One of the most important things to come away with from this seminar regarding generator piping installations and selection is to make sure the proper regulators are used. No generator installation should ever include a compact style regulator, whether it's a first stage or a second stage. Additionally, when we're sizing the second stage for a generator application, always make sure we size a REGO LV5503 series second stage regulator. These regulators are built with a larger diaphragm. It provides a smoother, more consistent pressure delivery, in particular to these high demand generators, and it will assure a smoother startup, in particular with any installations that you've had startup issues with in the past. Sometimes it's not possible to properly install a second stage regulator at a generator. We've worked closely with REGO and we've come up with a solution to some of those instances. Sometimes simply installing a LV4403 TR9 along with a LV5503 B8VO with a vent over outlet at the container and running piping from the outlet of the regulator to the inlet of the generator will supply enough pressure and enough BTUs to allow for a smooth generator operation. Of course, the piping has to be sized properly, the regulators have to be installed properly, and again, in particular, that 5503 series second stage is required to have a vent over outlet so it can be properly installed per NFPA 58 specs. What about sizing liquid propane piping? On page 47 of the REGO L545, there's a chart to do just that. You must determine what the total gallons per hour usage is at the point of use. You'll also have to determine what the distance between the container supplying the liquid is and the inlet to that piece of equipment. Once you've determined what the gallons per hour consumption is, and also the distance from the container to that piece of equipment, the chart makes sizing that liquid piping very simple. Here's a comparison between K-copper and Schedule 80 steel pipe when you're determining what pipe sizing to use for that liquid burning appliance that you're connecting to. I'd like to take a minute and discuss the differences between pressure testing and leak checking. Many times these are confused in our industry. Well, to start out, the difference between pressure testing and leak checking is pretty straightforward. Section 8.1 of NFPA 54 indicates that pressure testing is only done on new installations or when an existing installation is modified or added to. It's done at 1.5 times the proposed maximum working pressure of that system. It's done at not less than 3 psi for a minimum of 10 minutes in a single family dwelling. And also air, nitrogen, carbon dioxide, or an inert gas can be used for this test. By comparison, NFPA 54 determines that a leak check is required when the gas to a new piping system is turned on, when the gas to an existing system is turned back on after being turned off, or when the gas to an existing system is turned back on following an out of gas situation. Basically, this follows any interruption of service. That would determine that a leak check is required. Leak checking should be done when a system of new or modified gas piping is placed into service for the first time, assuming it's been pressure tested already, when a gas leak is suspected, when a gas meter is replaced, when an appliance or appliance connector is replaced, or when an out of gas condition or interruption of service occurs. Those are all key indicators for the requirement of a leak check. Leak checks can be done using tank pressure, high pressure, or inches of water column. A leak check must hold pressure for a minimum of 3 minutes. If tank pressure is used, before the check begins, you must drop that pressure 10 psi. If high pressure is used, you must drop that pressure a minimum of 2 psi. If water column is used, you must drop that pressure to 9 inches water column. This will unlock the regulator and allow the leak test to be done properly. If you review Annex C of NFPA 54, there are many more details and much more information on conducting a proper leak check. Once we have the pressure testing and the leak checking done, the next step is flow testing. Flow testing ensures that the lines are sized correctly. In flow testing, all of the appliances are turned on in the building. The pressure is checked at the outlet of the delivery regulator to make sure it's within specs. Once it's determined that the regulator pressure is set properly, without needing any fine tuning, the pressure is then checked at the appliances. Again, the appliances are under load when the pressure check occurs. The data plate on the appliances will indicate not only what the required inlet pressure is, but also what the manifold pressure is. A flow test will verify that the piping is sized accurately. It does this when you test the pressure at the appliance. If the appliance inlet pressure is within the manufacturer's specifications when the appliance is operating under full load, then the piping is properly sized. If the piping is not properly sized, the inlet pressure at the appliance will be low. If an adjustment is needed to the regulator, it's important to know that only fine-tuning the regulator or fine-tuning the regulator outlet pressure is allowed. Never adjust a regulator higher to make up for an undersized gas piping system. This is an example of what you would see at the outlet of a delivery regulator with the appliance at full load. In this case, we're getting 12 inches water column out of this REGO second stage regulator. Visually inspecting the flame characteristics on a propane gas appliance will not determine if the propane gas line has been sized properly. The only way to identify if the appliance is getting the proper amount of gas pressure is to put a manometer on the appliance. By looking at these two images, can you see a difference between these two burners with your naked eye? We're nearing the end of this presentation, but there are a few things that I think are important to point out with regard to using the tables in the REGO L545. You'll notice at the bottom of each table, you will see notes. What do these notes mean? There are different multipliers we can use if a different first stage pressure is needed. Table 1 is the first stage pipe sizing chart that we used earlier in the presentation. This table is based at an inlet pressure of 10 psi. But what if we want to run 5 psi in that same line as opposed to 10 psi? What do we need to do to calculate that that line is sized properly? In order to see if the line is sized properly for 5 psi instead of 10 psi, we basically need to fake out the chart. We need to take that overall BTU load, or that demand of 338,000, and multiply it by 1.12. What that does is it inflates the BTU demand that you compare to the chart. So for example, once that multiplication is done, you come up with a value of 378,560 BTUs. That is still greater than what the actual demand is, so therefore the line size would not have to be changed. It could remain half-inch copper tubing. We would use a similar exercise if we wanted to increase the first stage pressure. For example, if we wanted to go to 15 psi instead of 10 psi. In this case, we have that same 338,000 BTUs, but if we want to see what the capacity of that line would be at 15 psi, we're going to multiply the total BTU load by 0.912. We're actually, again, faking out that calculation and reducing what the overall load would be, even though we're technically not removing appliances or reducing the load. We're faking out the chart. So if we use our 15 psi multiplier of 0.912 against our original BTU demand of 338,000, it gives us a value of 308,256 BTUs. That number is what is used to reference the chart to determine what size piping would be adequate for 15 psi delivery service. In this case, if we use the 30-foot column, it tells us that 3/8 copper tubing would get us 309,000 BTUs. That is just over what our number is once we've used the multiplier at the 15 psi. So in other words, even though we needed 1/2-inch copper tubing for 10 psi, if we increase that first stage pressure to 15 psi, it now falls below the threshold of what the 3/8 copper tubing would handle. So therefore, with 15 psi, we can now reduce that piping size to 3/8. And of course, the same exercise would take place if we want to increase the first stage pressure to 20 psi. The only difference is that you would use a different multiplier, of course, and that multiplier would be 0.844. Essentially says that we would go from, again, 1/2-inch tubing at 10 psi to 3/8 tubing at 20 psi, because our new BTU demand, the new BTU value based on 20 psi and its multiplier, would be 285,272 BTUs. So therefore, again, you would go from 1/2-inch to 3/8 copper tubing. I'd like to thank you for watching this presentation on line sizing. Hopefully you picked up a few tips, not only on line sizing, but also on leak checking and pressure testing, as well as some generator application tips. Thanks very much and take care.